Hello, welcome back to the channel everyone. My name is Amos from Symmetry Acoustics. Episode ya leo, we want to keep it as simple as possible. Tunataka ikue very clearly understood. So tunataka kutumia lugha ya mtaa kiasi. In this channel we talk about room acoustics, especially Symmetry Acoustics. Symmetry Acoustics, we design products for professional audio use, like mixing rooms, professional tracking rooms, churches, offices, and any other space where noise control is required. So before proceed, nataka ni simplify some terms here ndio wasiwezi kuelewa what actually acoustic treatment is, because there seem to be a very big confusion between acoustic treatment and soundproofing. Saa zingine unapata mtu anakupigia simu na kuuliza, hey, you guy, have a problem with my room, it's too echoey. They call it echoey ama room sound, whichever term you can use to describe it. Wanasema room yao iko na echo mingi, they need it reduced, or the church is too noisy, the guys at the back cannot hear anything, or the office is too echoey, they cannot hear each other while talking. So all these scenarios will require some sort of noise control techniques, and that's where the term acoustic treatment chips in. So acoustic treatment is different from soundproofing, because when you talk about soundproofing, we talk about noise isolation. Noise isolation basically means separating the source of the noise from the listener, or separating the listener from the source of the noise. Is a two-way thing. So suppose to say I'm the listener and there's a source of noise somewhere, I need a barrier that blocks that noise from reaching me. Or if I'm working in a loud environment and I don't need to interfere with people adjacent to the next room, then I also need a barrier to protect the noise from reaching the other side. So that is where soundproofing is critical. So soundproofing is noise isolation, or constructing a barrier from the noise source to the listener, or from the listener to the noise source. So how do we soundproof? That is a very technical term. Soundproofing basically is some sort of construction work. It's basically construction work, because in some cases you will need to build a barrier using bricks or blocks and plastering it and all that kind of stuff. Kazi ya mjengo mnajua vile iko. So unajenga that barrier all the way from the floor to the ceiling and blocking one room from the next. Or you can use gypsum partitioning and some insulation materials in between the gypsum cavity to prevent noise transfer from one source to the other. So hiyo ndio inaitwa soundproofing. What you guys call soundproofing inaitwa acoustic treatment. So acoustic treatment basically is the process of applying acoustical techniques that will be able to reduce echo in any environment where noise control is critical, like I've said, churches, recording, mixing, tracking rooms, and mastering environments, and such like spaces. So how do we do acoustic treatment? Because this video is basically about acoustic treatment. Acoustic treatment, for us to get a good picture or a good result of what we expect, we need to look at, we call it material science. Which kind of materials are best suited for acoustic treatment? Conventionally, acoustic treatment, you require porous materials. Porous materials means materials that air can pass through easily. I have a sample here of acoustic foam. This one here is an open cell foam. Open cell foam means it's a foam that air can pass through very easily. If you pass air, if you try to maybe just blow through it, it's very easy to pass air from one side to the other. It's called open cell foam. What you guys sometimes use in your studios are not appropriate, because they are closed cell foam. The foam that is designed for couches, seating, beds, those are closed cell because air cannot pass through them. So when air cannot pass through them, simply the sound will not be able to pass through them. So these kind of foam are designed for acoustics. We also have rockwool panels or fiberglass panels. All those are porous materials that are used in acoustics to be able to reduce the amplitude of airborne noise and reduce the echo. So let's get to the second type of acoustical product that can be used to reduce echo, and that is acoustic diffusers. Diffusers are not very common for a lot of people, because the construction process is very complex, and then they are not very cheap. They are not cheap, but the result of a room with diffuser is interesting, because now the diffuser, unlike the porous absorber, these ones absorb sound, and then that's how we get energy loss. They turn sound into heat, and that's how we get energy loss. Diffuser diffuses breaks the huge wave of sound into smaller. I mean, fragments, I would use that term, that the ear cannot localize, the brain cannot localize. So you get a room that kind of sounds larger, but you don't know how it sounds larger. The diffuser breaks down the the larger sound that hits it into smaller chunks or pieces that the ear cannot localize or the brain cannot localize. So that's the role of a diffuser. It makes a larger room, a smaller room sound larger. Another product we have is low frequency management devices or bass traps. So bass traps are basically designed to absorb frequencies below 250 or 250 downwards, because that's the area that conventionally is referred to as bass area, 250 hertz all the way to 50 hertz. So any product that can be able to work and absorb frequencies around 250 hertz down to 80, 70, 60, and 50, that is referred to as bass trap or low frequency management. If it's a device that is able to absorb both low frequency and high frequency, we call that broadband absorber, because now it absorbs a wide range of frequencies from low to the high frequencies. So let's get to the type of acoustic product that you guys use that you guys are not supposed to use. Tuanze na egg crate. I still see people using egg crate, and I can't understand why you guys use egg crate. Egg crates are not appropriate for acoustical treatment, because they're not open cell. Air cannot pass through them. They also cannot act like a diffuser. As much as you can feel some difference, it's so negligible that it's not even worth mentioning. Another thing that you guys use that is not appropriate is those cushions, closed cell form. You may think that you hear a difference, but you don't. There's a project recently where we had to remove all of them in one of our clients' room and replace them with more appropriate panels. And also, we also have to measure. You cannot say something works kama uja measure. So lazima to measure, and then we see what difference that does it make. So acoustic form work from 50 hertz, 500 hertz all the way to maybe 1 kilohertz and above. They don't work below 500 hertz very well, unless it's a uniquely designed form. So those are some of the properties of these products that make them very suitable for such kind of work. Another thing that is very crucial that most manufacturers will never tell you, there's something we call gas flow resistivity. I think gas flow resistivity is king, because I'll be sharing with you this calculator here. You can check this out. You can see that this calculator, it has 3 parameters. It has flow resistivity, gas flow resistivity, it has thickness, and also it has air cavity or air gap behind the panel. So as you can see, if we put our panels at 100 millimeters or 10 centimeters, and then we give it a flow resistivity of around 10,000 kilopascal, which is the unit of measure for flow resistivity, and then we play with a bit with the air gap, you can see that all these 3 parameters, they have to kind of balance together to give you the best possible sound absorption. As you can see here, if we increase the thickness to maybe 15 centimeters, for instance, and then we also increase flow resistivity of the material, then you can see that the difference is not as much. But if we reduce the flow resistivity or the porosity of the material, then we start to get some very decent absorption towards the lower end. So when you're making your acoustic panels, it's important to also consider flow resistivity, which I know a lot of you guys don't consider. And that's why professional made panels will always work better than the DIY or the one you make yourself, because the manufacturer knows which flow resistivity to apply to which kind of acoustic panel. Because you find that thinner panels, like 2-inch panels, will require a slightly higher flow resistivity to be able to absorb sound better compared to a thicker panels. So when the manufacturer is making a thicker panel, probably 15 inches thick, they tend to go with the low flow resistivity. As you can see here, the thicker the panel, the lower the flow resistivity, the higher the absorption towards the lower frequency. So that is something also you have to consider, and that is just part of the features that you have to take into account before you try to build anything. Let's get to another point in a while.